the sum, sine squared 1 degree plus sine squared 2 degree plus sine squared 3 degree all the way up to sine squared 90 degrees is equal to one of these possible numbers. All right. So my thought here is that my first instinct is that maybe these things come in pairs. So something like, if we throw in sine squared of 0, which is equal to 0, then I have sine squared of 0 and sine squared of 90, sine squared of 1 and sine squared of 89, and so on. And maybe there's an identity we can use for something like that. I'm not sure if there is. Well, let's write this out. I'm going to write this as sine squared of 0 plus sine squared of 1. Everything will be, it'll be implied that it's all in degrees. I don't typically like writing things in degrees, even with the symbol. You should always use radians. But my suspicion here is that, with the way this is worded and so on, the fact that we're using degrees here doesn't really matter. It's going to be more about the number of terms that are involved. So, can I say anything about let's write this as sine squared 0 plus sine squared 90 plus sine squared 1 plus sine squared 89 plus sine squared 2 plus sine squared 88, and so on. We'll have to keep track of exactly what that so on means, right? There's clearly a number that is not repeated, and I guess it's, or does not have a corresponding pair. Sine squared 45 does not have a corresponding pair. This is sine squared of 0 plus 1 minus cos squared of 90 plus sine squared of 1 plus 1 minus cos squared of 1, sine squared 2 plus 1 minus cos squared 2. Oh, sorry. That's an 89. Cos squared of 89. Sine squared of 2 minus 1 minus cos squared of 88, plus and so on. Now, sine of 0 is 0. Cos squared of 90 is 0. So this is 1. Sine squared of 1 and cos squared, sine of 1 is equal to cos of 89. If you look at, if you think about what these functions look like, so that's 90 or pi over 2. Sine looks like that. Cosine looks like that. Well, they're the same function after the appropriate transformation, after doing 90 minus x. So each of these is going to evaluate to 1. I have 1 plus and so on. It's just the last number, sine squared of 45, which is the one that's missing. So this should be 44 plus sine squared of 45, which is 44 plus sine squared of pi over 2. Sine of pi over 2 is 1 over root 2, so this should be 1 over 2. So, oh my goodness, and they're even writing the answers as improper, or what do you call these, mixed fractions? Oh, please don't ever do this. Like, is this 44 times a half or 44 and a half? I mean, that's the only answer that they give which corresponds to what I had. That's option B. I really do not like that they've... I don't mind that much using degrees, but you explicitly notating that all of these values are in degrees. Very important in any kind of examination question, otherwise you're being unnecessarily ambiguous. Right? If these were all in radians, you're perfectly fine asking this question where all the arguments are in radians. But the fact that things are going from 0 to 90 is pretty suspicious. But giving the options written as these mixed fractions is just not... You really should not do that. The way it's written, like this, I'm sorry, but that's the common notation for 44 times 1/2. Anyway, I really hope that's what they intend for the answer to be. That's the answer I end up getting, unless I made a mistake somewhere. You get all the cancellation of all these things. So does this say that... Yeah, I guess it's correct in saying that sine squared of x plus sine squared of pi over 2 minus x, this is equal to 1, because that's equal to cosine squared of x. Okay. Yeah, so that's my answer, as much as I don't like the way it's written. But if I have a mistake, I'll let you know. Thanks for watching.